Welcome back. So we're going to go into MLOps with AWS. But before we get started, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. So machine learning operations, or MLOps, encompasses the practices and tools for deploying, monitoring, and maintaining machine learning models in production. AWS provides integrated services for safe deployments, edge computing, cost optimization, and continuous monitoring. So deployment guardrails and shadow testing. Deployment guardrails enable safe model rollouts to production endpoints without risking stability. Blue-green deployments run both old and new model versions in parallel. 3 traffic shifting modes control the transition. All at once switches immediately. Canary routes a small position first, and linear gradually increases traffic over time. Auto rollbacks revert to previous versions if health checks or metrics degrade. Shadow tests route copies of inference traffic to shadow variants that don't serve real results, allowing manual performance analysis before promotion. This evaluates new models under real workload without risk. Okay, so a little bit about this is shadow. Did I get that? All right, I didn't put that one up there. Okay, never mind. Okay, so blue-green deployments. In SageMaker, under endpoints, you're gonna create an endpoint configuration, and under the production variants, you can add multiple variants or enable traffic shifting, and then select the shadow variant to minor production traffic without, or excuse me, to mirror production traffic without serving results. And you can set rollback conditions via CloudWatch alarms to automatically detect and respond to degraded performance. Okay. So let's see. Containers. Let's talk about that. Okay. So SageMaker training and inference jobs run inside Docker containers. Is this? Yeah. So these containers are either pre-built for TensorFlow, PyTorch, and XGBoost, or custom containers you can provide. Key paths within containers include opt/ml/code for training scripts, opt/ml/input for channel data and configuration, opt/ml/output for checkpoints and errors, and opt/ml/model for saved model artifacts. Those custom Docker containers require predictor.py with Flask app handling prediction requests, train.py containing training logic, and nginx.conf with wsgi.py for unicorn server setup. It's a lot. All right. Okay. So production variants serve multiple models under a single endpoint for A/B testing. You can configure the variant weights to control traffic distribution. So you could have 90% to version 1, 10% to version 2, and adjust dynamically based on your performance. All right. So edge deployment. So SageMaker Neo compiles train models into optimized code for edge deployments on ARM, x86, and NVIDIA hardware. This enables local inference on smart cameras, vehicles, and factory sensors without constant cloud connectivity. Neo integrates with IoT, or Internet of Things, Greengrass for deployment, AWS Lambda on devices for real-time actions, and SageMaker Studio for management. The workflow trains in SageMaker using TensorFlow, PyTorch, XGBoost, or ONNX, and compiles with Neo targeting specific hardware, then deploys via Internet of Things Greengrass. Excuse me. Let's see. Yeah, this is something about Greengrass. So a little bit about Neo. So in SageMaker, you go to Neo, select your train model, specify a target device architecture, think like ARM64, right? And then you can compile the model and download the optimized artifact and use Greengrass or the console to deploy the compiled model into edge devices. All right. Okay, let's see. Instances. Okay, so deep learning algorithms require GPU instances like the ML.P or ML.G type, right? Classical ML algorithms run efficiently on CPU instances like ML.M, ML.C, and this inference is less resource intensive. Often ML.C or ML.T are medium instances that can suffice. Additionally, you can do spot training using EC2s to cut costs up to 90%. But this introduces wait time and potential interruptions. And that's what we were talking about checkpointing much earlier, right? Spot training requires checkpointing to S3 to resume after interruptions, right? This is basically like saving your game. And you can configure this through the SDK or through the console. And then you can provide that checkpoint S3 to make sure this happens. Okay. Okay, automatic scaling. So automatic scaling adjusts endpoint instances based on real-time traffic and CloudWatch metrics. You can configure minimum and maximum instance counts, cooldown periods, and target utilization thresholds. Scaling applies to each production variant separately. For resilience, deploy across multiple availability zones by configuring two set subnets in a VPC for fault tolerance. I'd say at least two. All right, but remember your costs will increase. All right. And deployment. Okay. So SageMaker offers 4 deployment modes. Real-time provides low latency request response. Async handles long-running jobs with large payloads. Batch processes offline workloads. Serverless auto provisions capacity for irregular traffic, scaling to 0 when idle. Deploy via SageMaker Jumpstart for one-click pre-trained models, Python SDK with Boto 3, or CloudFormation, Terraform, using the resources for them. So let's go a little bit into serverless. So serverless inference auto provisions capacity, scales to 0 when idle, and bills per request based on milliseconds and memory consumed. It suits spiky or unpredictable workloads tolerant of cold start delays. Monitor this via CloudWatch metrics, tracking setup time, memory utilization, and error counts. SageMaker Inference. So Inference Recommender benchmarks models on different instance types, offering recommendations based on latency, throughput, and cost. Instance recommendation mode runs 45 minutes. Endpoint recommendation mode performs custom tests over approximately 2 hours. So when you run recommendations, register your model in the SageMaker model registry, open the Inference Recommender, and choose the benchmarking mode. Review the cost and latency results to select the optimal instance types for your workload. Let's see. I thought that would be on this one. Okay, so let's talk about, okay, inference pipelines. Okay, so inference pipelines chain 2 to 15 containers for pre-processing, model inference, and post-processing. Apply transformations like scaling or text tokenization before inference, then post-process results with thresholding or JSON formatting. Pipelines work with both real-time inference and batch transformation. Configure this through the SDK by creating a pipeline model with an array of models, preprocessor followed by predictor, then deploy as a single endpoint. Okay, model monitor. This detects and alerts on data drift, model performance degradation, bias drift, and feature attribution drift. It integrates with Clarify for bias detection, CloudWatch for alerts, S3 for log storage, and visualization tools like QuickSight, Tableau, and TensorBoard. Tracked metrics include input feature statistics like mean and standard deviation, performance metrics like accuracy, RMSE, and precision. Feature importance show score drift and outlier detection. So when you set up monitoring, you'll be in SageMaker Studio, you go to model monitoring, create a baseline from the training data, and then show the expected distributions, right? You can schedule the monitoring jobs to compare production data against the baseline, and you can review the violations in CloudWatch logs or the dashboard and configure alerts for automated notifications. Data capture. Okay. So data capture logs all endpoint input and output for retraining, debugging, and auditing. Data stores in S3 with optional encryption, supporting both real-time and batch inference. Configure this via the SDK or the console, and then you can set the destination to that S3 URI and capture options for input and output. And then finally, cost. So serverless inference bills per request. This is ideal for low flow traffic scenarios. However, managed endpoints charge per instance hour, and they scale down during off-peak hours. Spot training offers discounted EC2s, but requires checkpointing so that you don't basically lose your information, right? And then Neo and Greengrass add no extra fees beyond edge device costs. Model Monitor charges per job and storage, and you regularly must prune logs in S3 to control expenses. So for the exam, remember this. When the questions ask about model deployment, edge inference, cost optimization, or production monitoring, understanding these MLOps capabilities demonstrates practical knowledge of managing machine learning systems at scale. All right, so thank you for joining. That will be all for this one. Before you go, hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning Associate exam. Thank you. Have a good day.